Today we're going to talk about our last section in chapter 8. We're going to talk about comparing proportions from two different populations. So far in this chapter, when we've been doing our hypothesis test, we've just been focusing on one proportion. In this section, we're going to go through kind of a similar procedure, but we're going to compare two different proportions instead. As we're going through these sections, to save a little bit of work and to save a little bit of calculations, we're just going to be going through these examples using StatCrunch. Right, so as far as our steps go, our steps are still going to be the same. We're still going to use our same 4-step procedure, come up with a pair of hypotheses, prepare, so check our conditions, do our computations, and then interpret our results. We're just going to make some minor changes to our hypotheses, our preparations, and our test statistic. Right, so for our hypotheses, instead of saying that our P is equal to a value, our null hypothesis is going to be that P1 equals P2. And this is going to be the same for all of our different possibilities for a test, one-sided or two-sided. Then for a two-sided test, our alternative hypothesis is going to be that P1 does not equal P2. And then for our other two one-sided alternative hypotheses, we're going to use either a less than sign or a greater than sign. So unlike what we saw for our one proportion test, we're going to see two proportions, and we're not going to have any number values in our hypotheses. We're just going to have P1s being compared to P2s. All right, as far as our preparations and our conditions go, the big thing that we want to look for is that we are checking these conditions for both of our samples. Right, so that both samples are random and independent. They're random and independent from each other. Right? Both are large enough samples, and both have a large enough population. Notice that we do have a p-hat value mentioned here. We're going to define it on the next page, but we can also define it kind of using notation that we might be familiar with. So if we see just a p-hat with no subscript in this case, so we're not looking at P1 or P2, our p-hat is going to be our number of successes from our first population plus our number of successes from our second population divided by the total number in our sample from both populations. So we're going to take x1 plus x2 divided by n1 plus n2. Right, on the next page of our notes, we see our calculation for our z value. Again, you're not going to have to work through any of these by hand, so I'm not going to spend a lot of time talking about this formula, but I do just kind of want to mention this p-hat value that I just mentioned on the previous page. Right, the number of successes in sample 1 plus the number of successes in sample 2 divided by n1 plus n2. So this is kind of just in here for your reference at this point. At the bottom of this page in our notes, we do have our steps for finding our p-value and doing a two-proportion hypothesis test. Right, we're going to go to stats, we're going to go to proportion stats, but unlike the other ones that we've done in this chapter, we're going to go to two samples, kind of like we did in the last section in chapter 7. We're going to select with summary. We're going to make sure we enter the number of successes and number of observations for each sample. Right, so our x1, x2, n1, and n2. We're going to select hypothesis test, make sure we enter our correct pair of hypotheses, and then select compute. All right, so we're going to go through two examples. So to start with, for this first example, a student is interested in determining if there are gender differences in texting while driving. She collects data from a random sample of 80 men and 60 women. Of the 80 men, 38%, or excuse me, not 38%, just 38 reported that they had texted while driving. Of the 60 women, 27 reported that they had texted while driving. Assume the samples were random and independent. Can the student conclude that the proportion between men and women who text while driving are different? Use a significance level of 5%. All right, so we're going to start by listing what we know. So our population, right, is going to include everybody in both of our samples. So our population is going to be all adult drivers. Okay. Our first population, we're told to let P1 be a proportion of men who texted. Okay. So there were 80 men that were surveyed or sampled. So that's going to be our N1. So our N2 is going to be the 60 women that were surveyed and sampled. Okay. All right, P1 hat. Well, that's going to be our proportion of men. So of the 80 men, 38 reported that they had texted while driving. So our P1 hat is going to be 38 divided by 80, which gives us 0.475. Okay. P2 is the number of women, so 27 out of 60, which is going to give us 0.45. Right, our P hat is in essence pretty much an average of these two. Again, to figure out our P hat, again, we're going to take x1 plus x2 divided by n1 plus n2. So we're going to take our 38 plus 27 divided by 80 plus 60. That's going to give us 65 out of 140, and it gives us 0.464. So notice that this percentage is somewhere in between our two other percents. Right, our level of significance, we are told that alpha equals 0.05, and what we are being asked are the proportions different. Different meaning we're going to use a not equal to sign. All right, so then our first step of our process, we're going to state our hypotheses. Null hypothesis is always that P1 equals P2. Right, this is never going to change throughout the section. Our alternative hypothesis, we're going to use the symbol that we just mentioned in the question above, that P1 does not equal P2. All right, so our first sample here, we're going to look at our proportion of men. All right, so our sample is random and independent. Yes, we are going to assume that that is true because we are told so. All right, at least 10 successes and 10 failures. All right, so we're going to take this P hat value that we have up here and use that for our conditions. So we're going to take our N1, our sample size for men, which is 80, times our P hat, which is 0.464, which gives us 37, which is bigger than 10. And then we're going to take 80 times 1 minus 0.464, and that's going to give us 43, which is also larger than 10. Right. All drivers, so our population, greater than or equal to 10 times 80 or 800. Right? We can also safely assume that there are more than 800 drivers. Now we're going to check our conditions for our sample of women. Okay. So our sample is random and independent. Yes, we are told so. Right? Now we're going to use our sample size for women, which is 60. So 60, we're still going to use the same 0.464. Right? That's going to give us 29. Right, which is bigger than 10, and 60 times 1 minus 0.464 right, is going to give us 31, also greater than or equal to 10. Again, all drivers, if we multiply 10 times 60, we get 600, right? So we are greater than 600. All right, so from here we're going to go to StatCrunch. Right. As we're going through and we're doing these, again, we want to make sure that we keep everything straight. Right? So when we enter our different values, our X1 and N1, remember, is our men. So when we do this, we're going to use the actual values that we were given in our problem. So for our population of men, right, we had 38 successes, and there were 80 men that were surveyed. Right, for the women, we had 27 out of 60. So when we enter these values into StatCrunch, we want to be sure that we use those values. Right, once we select compute, then we are given that Z equals 0.29 and P equals 0.77. Right, so now we're going to compare P to alpha. So 0.77 to alpha 0.05. Right? P is greater than alpha. P is greater than alpha, which means we are not going to reject our null hypothesis. All right, so we go back to our pair of hypotheses. Right, we are not going to reject our null hypothesis, so we're going to circle that one. All right, so that means we're going to cross off our alternative hypothesis. All right, so that means that these two proportions could be equal. So since those two proportions could be equal, our interpretation, we are going to write, we cannot conclude there is a difference in the proportions of men and women who text when driving. Right, so again, we don't want to use words like proved or something along those lines, but in this case we cannot conclude that there is a difference in the proportion of men and women who text when driving. All right, so let's work through one more example. Right, researchers from the Gallup poll interviewed 2 random samples of American adults. Both samples, one taken in January 2014 and one taken in January 2015, had 3,500 people. In January 2014, 1,575 respondents said they felt pretty good about the amount of money they had to spend. In January 2015, 1,715 respondents felt this way. Can we conclude that the economic confidence has improved since 2014? Right, so based on the difference of 1,575 people in 2014 to 1,715, we want to know, is there an improvement, right? Can we conclude that economic confidence has improved since 2014? Right, so we're going to start by listing off everything that we know. So our population, right, we are looking at all American adults. Right. We are told to let P1 be our proportion in 2014, P2 be our proportion in 2015. Right. So there were 3,500 adults sampled in 2014. Out of those 3,500, 1,575 said they felt pretty good. So that is 45%. Right. So that was 2014. We also have 3,500 adults in 2015. Right. 1,715 divided by 3,500 gives us 49%. Right. So to average these, again, we take x1 plus x2 over n1 plus n2. 1,575 plus 1,715 over 3,500 plus 3,500 gives us 3,290 out of 7,000, which is 0.47. This one turns out to be an exact average of our two percentages because our sample sizes were the same. Okay. Our level of significance, we're told, is 5%. Right? And what we are asked is, has confidence improved? Okay. So what that means is P2 bigger than P1? Right? Has our confidence improved? When we're writing our inequality statements, we want to be sure that we start with P1. So we're going to start with P1 less than P2. All right, for our hypotheses, our null hypothesis is that P1 equals P2. Our alternative hypothesis is going to be this P1 is less than P2. All right, so we're going to check our conditions. We're going to assume that they are random and independent. We're going to take this 3,500 times 0.47 we get 1645. 3,500 times 1 minus 0.47 gives us 1855. Right? And then our large population is going to be that of all Americans greater than or equal to 10 times 3,500, which is 35,000. There are more than 35,000 people in America. In our next one, these should all be N2s. But if we look at these are actually going to be the exact same as population 1 because our sample size is the same. So we don't need to recheck these since they all worked for our first population. They will also work for the second population. All right, so then we're going to go to StatCrunch. As we're working through StatCrunch, again, we're going to go to proportion stats. Right? This time, instead of selecting one sample, we're going to select 2 samples. We're going to make sure we enter our number of observations and number of things in our sample for each different one. After we hit compute, we get z equals negative 3.35, p equals 0.004. So then we're going to compare p to alpha. 0.004 is less than 5%. So since p is less than alpha, that's going to tell us that we are going to reject our null hypothesis. Alright, so going back to our problem, we are going to reject our null hypothesis, which means we're going to conclude that our alternative hypothesis is true. Right? That tells us that P1 is less than P2, which what we were asked originally was, has confidence improved? So we are going to say we can conclude that the proportion of American adults with consumer confidence has increased. Okay, so as you're working through problems in these sections, again, in comparison to everything else that we've done in Chapter 8, here we are looking at 2 different samples in the same population instead of just one, and we are making our hypotheses and our comparison based off of those 2 different proportions.